Hi guys, this is Topographic Maps lesson 2. So I just wanted to do a quick recap. The last time we talked, we did the Play-Doh topographic map making with our pieces of our Play-Doh mountain here. Then we quickly talked about how close lines on a topographic map represent steeper slopes. The lines are referred to as contour lines. Every line is a contour line on this map. Lines that are darker in nature, and we'll look at that in just a second, which have numbers, they're referred to as the contour index lines. They're dark, shaded in very dark, and they have numbers associated with them. Not every line normally has a number, but sometimes they do. Then we said if the base of the mountain has no elevation associated with it, it might be at ground zero. You need to check based on the index lines provided or the ones with numbers. The further the contour lines are spread apart, the shallower the slope is, so it's really a gentle slope and easy to go up. And every contour line represents a change in elevation. So let's look at, I want to look at this map with you for a second, because then you might need to pause and take some notes, just ensuring that we have all the information we need. So all the lines on this map, on this flat map of a topography or landscape that has hills and valleys, this one also has contoured lines that are numbered. Everyone is numbered. Normally you might see one that's shaded in dark. Let's just say this one is a contour index lines. So contour index lines are shaded darker. So if this one didn't have a number, this would give us an indication of what elevation this line was. So the darker lines are contour index lines. All right, so with that being said, usually on the map it'll tell you the contour interval. This one doesn't, but in general, contour interval just says by what the lines are counting, by what elevations. So if we look at the change in elevation on this map, here we see 100, here we see 200, here we see 300. So obviously this is counting by what? Counting by 100. So for this map alone, the contour interval would be 100. We don't know if it's feet unless it's been indicated. It might be feet, it might be meters. We're just going to say it's feet for this particular map. When you follow a contour line, the contour line, every line itself is only associated with one height or one elevation. So I can follow this line, the 300 line, all over the map, and it's always going to be 300. This one here, always going to be 400. So make sure that you understand that the lines don't cross. These contour lines never cross one another, and they show a specific elevation. Even if they don't have the number, let's say you didn't have this number, this number, you had 100, and then the next line was the fifth line. It would be dark, so that would be the next contour index line. So 100 to 500, then you'd have to count. You'd have to either figure it out what the contour interval is, what they're counting by, or you'd have to look at the map and see what it says. This one, I just told you what it's counting by, but if it didn't tell us, you know that 100, you can try it out. Usually contour maps count by 10s, 20s, 50s, some count by 60s. and then hundreds or 200s or thousands, depending on what type of landscape they are trying to show you on a flat sheet of paper. So let's say we didn't have these. We'd say, okay, 100, this is 500. I know this. We wouldn't know any of this. Okay, so 1, 2, 3, 4, 5. I got it real easy. And we'll practice that some more as we go. We've already said that the further the lines are, the gentler the slope. And the closer the lines are, the steeper the slope. Why might that be important information? Well, if you want to go hiking this mountain, you might choose not to go up the steepest side. You might want to go a very gentle hike to the peak. And that brings us to, well, how many peaks are there? In this map, there's actually one peak here, Berry Mountain, right? And one peak here, Deer Mountain. This right here, this is the different type of line. This shows a contour line with little hatchet marks on it going towards the inside. This represents a depression. Okay. So let's go through the notes first and we'll dissect this map a little bit more. So we know the contour index lines are the darker ones that have a number usually associated with it. Most of them only have those numbers on those lines. The contour interval means what it's counting by. So what are the lines counting by? What is it? Is it 10s, 20s, is it 30s? Excuse me. Whatever. They are used to represent hills or mountains on a flat surface, and they tell about the terrain or landscape of that area. Okay? All right. Sometimes on a topographic map, you'll see an X or a triangle showing the peak of a mountain. So for example, on this one, we see X. Here's the X. This means that Berry Mountain here is at 8. Well, let me backtrack. The line before you get to the X marks the spot is 800. Okay? We said it's feet. So if this line is 800 feet in elevation or high, the X comes inside of that line, meaning that where X is, it has to be greater than 100, than 800 feet, because it's not on the line. It's above that line. So it has to be greater than 800 feet. It could be anywhere between 801 feet to, well, what would the next line be? The next line, if there was another contour line, being that these are counting by 100, would be 900. So it's going to have to be between 801 to 899 feet. It cannot be 800 because it's not on the line. The X is not on the actual contour line marking 800 feet. It is above that, but it's not high enough above that to have another contour line to indicate 900. So it has to be greater than 800, but not above 899. On this map, as you see, the X's mark the peaks of these mountains. So same for Deer Mountain. At Deer Mountain, the X is here. It is not on the index line. So that means that Deer Mountain has to be above 801 feet. And just like we said, there's no extra contour line to indicate 900 feet. So it's above, it's at least from 801 to 899, somewhere in there. We don't know exactly where because on this map they didn't tell us. Sometimes if you get an X or a triangle to mark the peak, you'll also get a number associated with it. So if the peak of the mountain is represented by an X or a triangle, it may also have an elevation, so a number, elevation, associated to the peak. Maybe. Not always. Like on this map you don't. Some you do. Everyone's a little bit different. So I tell kids, you know, when you're looking at these and you're asked questions about direction, look for a compass rose. A lot of these have a compass rose associated with them. If not, and you're asked about direction, do your own. Never eat sour watermelons. There you go. Do your own, and that way you can say what direction, what is. When we made our own, we noticed that if you have in your contour lines, if you have little arrows kind of pointing towards the mountain and you see a line cutting across it, that would indicate some kind of stream. This one says it's Camel River. So here's the river. It's coming downhill. It's not going uphill. Even though the contour lines point towards the top of the mountain, the actual water is flowing downhill. If I asked you in what direction was this Campbell River flowing, you'd probably say, what is it? Like, kind of like that. So, pretty much southeast, right? Southeasterly direction. All right. We already mentioned this, but I'm going to go over it again. The elevation or the height of every line is always the same, the whole line. It never changes, and they do not cross. And then here we have that also indicated, an upside down V. This V going towards the top of the mountain shows a river flowing in the opposite direction, in this direction. So make sure that you pause this, look over the notes, make sure you got them all, and we're going to move forward. And we're actually going to go ahead and do a practice topographic map so that we can practice our reading, topo map reading. If you have any questions or anything, let me know, and I'll see you later. Bye.